Hello, ladies and gentlemen. Today we're going to be taking a look at solving rational equations. Today our method is a little bit different than what we've been working on. Today we're going to be looking at when there are three or more fractions that are involved. So this is a bit different than before. For this you're going to need those notes again, something to write with, and a calculator. So we're going to start again by looking at that objective. What we're trying to do here is learn how to solve these rational equations with three or more fractions. So solve an equation when we have three or more fractions there. So let's think back or think about a simpler problem where we have a rational equation here, where we have fractions, that is. So if you take a look at this, I have 1/7 plus I don't know sevenths equals 5/7. And so you might say, hey, I kind of already know what goes in that box right there. I already know that number. To make the 5/7, I know what I would have to add to 1/7. But let's use this simple idea to kind of get an understanding about what we're going to do today. Let's pretend this is an x right here. And if I were to add these two fractions together because they have common denominators, I would get 1 plus x over 7. And the other side is 5/7. And now if we wanted to undo this whole idea of having a fraction, as long as we're doing the same operation on both sides, I could, in this case, multiply this side by 7 and multiply this side by 7 to cancel those 7's there. And I have 1 plus x equals 5, and if you subtract the 1, you get x equals 4. So let me ask you this. Did you figure this out without really doing that whole multiply by 7 on both sides sort of business? Maybe. Because those common denominators were the same on all three fractions, your eyes just went to the top, the numerators, and said, what has to go where that x is in order to make 1 plus something equal 5? So really the common denominator wasn't really that important in the solving process, except that we need to make sure we have a common denominator there so that we're speaking about the same type of terms. So let's use that same idea here. I have three fractions. The x is in a different location. 1/2 plus 2 over x equals 1 over x. Now in order to solve this problem, first we're going to need to make sure that we have common denominators because I have to add two fractions on that left side. So to make a common denominator, remember here's where we kind of take that little table and we ask ourselves, what does fraction 1 have? Fraction 1 has a 2. What does fraction 2 have? It has an x, so I'm going to make a column for an x. And what does fraction 3 have? Fraction 3 has an x. So if I look down my rows and my columns here and all the different rows that I have a 2 and an x. So my lowest common denominator, my least common denominator is 2x. That means that each of those fractions need to have a 2 and an x as their least common denominator. And now we do what we've been doing in class. If we compare the before and the after, if this fraction was just 2 and now it is 2x, what did we multiply by? We multiplied by an x, so the top needs to be multiplied by x as well. Now the second fraction had an x, now we have a 2x, so it was multiplied by the 2, so we have to multiply the top by 2, making him 4. And then the last fraction had the x already, and is now 2x, so he was multiplied by 2. So we'll multiply that one by 2 as well. And now if we look at what we have there, notice that the lowest common denominator is 2x, and it's the same on all three fractions. So if I wanted to, I could multiply both sides by 2x, which would in essence cancel out these lowest common denominators here, leaving me with just the x plus 4 equals 2. So once I have established common denominators, my brain can focus on solving those numerators, that equation up there, to figure out what the x value is. X plus 4 equals 2. So what would that be then if I tried to solve this? Well, I'd subtract the 4. Subtract the 4, x equals -2. Awesome. Now let's check it and see if it works, just to be sure. So if I take that -2 and I plug it back into the original equation, I have 1/2 plus 2 over -2 equals 1 over -2. 1/2, this is -1, so 1/2 minus 1. Is that the same thing as negative 1/2 that's showing on the other side? Yeah, this is negative 1/2, so is this side. So it checks, it works out. X equals negative 2. So again, the whole summary of this process is get those common denominators the same, then solve that numerator, okay? So let's take a look at another example here, example 2. So again, we have 3 pieces here, and you might only see 2 fractions, but let's remember that this 2 is really over just a 1 here, so he is technically a fraction, okay? So before we can start, we need to make a common denominator. So there's my little chart. I have 3 fractions, so I have 3 rows. Fraction number 1, what do you have? I have an x plus 1. Fraction number 2, what do you have? He has an x squared minus 1, which if we remember, that's the same thing as x plus 1 and x minus 1 in factored form. So he has x plus 1 and x minus 1. Fraction number 3, what do you have? Oh, just a regular 1. Okay, so I'll make a new column there. So my lowest common denominator, guys, has to have an x plus 1, an x minus 1, and just your standard 1, which if you multiply by x plus 1 times x minus 1 isn't really going to change anything. So the lowest common denominator, LCD, I'm going to label it there, are those pieces that we've listed there out of those columns. So I'm going to write those for 3 fractions. This is going to be x plus 1, x minus 1, and again, if you put that little 1 there, it's the same thing. Multiplying by 1 won't change anything. So x plus 1, x minus 1, x plus 1, x minus 1. Okay? Lowest common denominator. So now I've established all of them, and now I just need to change the numerators to reflect how I change those denominators. So back up to fraction 1 here. He had an x plus 1. What's new? Well, I multiplied by another 1, which isn't going to change the 3x at all. And I multiply by an x minus 1. So I need to multiply the top of that first fraction by x minus 1, making him become 3x squared minus 3x. Second fraction. You had x squared minus 1, which essentially is x plus 1, x minus 1. That's what it looks like in factored form. So we really didn't change anything. I'm going to leave you a 12. And fraction number 3 here, we got a problem. He just had a regular 1 down there, just 2 over 1. And we need to multiply him by x plus 1 and x minus 1, both parts. Now, if you remember, we talked about how this is the same as x squared minus 1. Remember, that's his factor form? So it's easier usually to multiply the 2 times the x squared minus 1. Since that's equivalent, we can do that. So he becomes 2x squared minus 2. And now that the common denominators have been established and they're all the same, you guys, now we just focus on solving these numerators. Okay, solving that equation, because the lowest common denominator would essentially cancel out if I multiplied by the lowest common denominator here, and if I multiplied by the lowest common denominator on this side. Yay, leaving me with just those numerators. So I'll just solve 3x squared minus 3x equals 12 plus 2x squared minus 2. So I'm noticing there are x squareds in here, so I pretty much want to get them together on one side. So I'm going to subtract these 2x squared, subtract these 2x squareds over here. I'd have x squared minus 3x. On the other side, I'd have a 12 and a subtract 2, which is 10. Now, since I have an x squared and an x, I want to bring that 10 over there to hang out with the rest of them, making x squared minus 3x minus 10 equals 0. Now, do you see what we're going to do? Hopefully, you realize that this is going to give me 2 solutions. This is a factorable problem that can give me 2 solutions. So what multiplies to make negative 10 and adds to make negative 3? Negative 5, positive 2. So one solution, if I take x minus 5 and set it equal to 0, x equals positive 5. And the other solution is x equals negative 2. So notice we got 2 solutions here. And we want to maybe check to make sure everything's okay, that we didn't in fact break that rule that says we can't divide by 0. So you want to go back now and plug these in and make sure that they work. Make sure that there are no extraneous solutions. But for the sake of time right now, I'm just going to go on to the next one, okay? So here's example 3. Let's take a look at this one. We need to make some common denominators again before we can start solving that problem. Here we go. Top, notice the 3 rows there for my 3 fractions. This is how I organize to make my common denominators. Let's take a look. What does fraction number 1 have to offer? Just an x plus 1. Can't be separate, okay? What does fraction number 2 have? A 2 and an x. Now there's no plus sign in between. Those two are factorable into 2 times x. They're 2 different things, okay? And then fraction number 3, you have just an x. I'll put him in the x column. And now my lowest common denominator then, my LCD, my lowest common denominator, would have the x plus 1 from the first column, the 2, and the x. And if you want to, you would simplify that as 2x times x plus 1. Okay? So that's my lowest common denominator for all 3 fractions. So I'll write my lowest common denominator is the 2, the x, and the x plus 1. The 2, the x, and the x plus 1. The 2, the x, and the x plus 1. And now I compare before and after. Fraction 1 had x plus 1. He now has 2x times x plus 1. So I need to multiply by 2x. 3x times 2x is 6x squared. Fraction number 2 had 2x. Now there's an x plus 1. That's new, so I need to multiply the 6 times x plus 1, making 6x plus 6. Fraction number 3, you had just x. Now you have another 2 and an x minus 1, so I need to multiply this by 2 and an x plus 1. So that's 14 times x plus 1, so it becomes 14x plus 14. There we go. And now to go about solving this, go ahead, we're going to take these guys right here, solve that numerator, try to figure out what we have going on. We have 6x squared plus 6x plus 6 equals 14x plus 14. And we're going to bring everybody to hang out over here on the other side. Minus 14, minus 14, 0 on this side, yay. And we have 6x squared minus 8x minus 8. Cool. And then we need to factor him. We need to get our 2 solutions. Look at that 6, the 8, and then another 8 here, 6, negative 8, negative 8. Let's divide all of those by 2. 2 comes out. We'd have 3x squared minus 4x minus 4 equals 0. Okay, so now by taking that 2 out, we made something that has a few smaller numbers in here. We need to factor still some more. 3 times negative 4. What multiplies to make negative 12 and would add to make negative 4? Negative 6 and 2 would do that. So I'm going to go ahead and place them in the AC method boxes here. So 3x squared minus 6x, 2x, and then minus 4. I'm going to take out a 3x, take out a 2, take out an x, take out a negative 2. So this factors into 3x plus 2, x minus 2, and that 2 that's hanging out in front. Now, if you remember how we solve these now, we want to look and solve each little factor separately. So we're going to solve for the x here, solve for the x here. This little 2 guy right here, if I divided both sides by that 2, he would essentially cancel out. 0 divided by 2 would still be 0. So we're only solving those factors with x there. And if we continue solving, we'd get x equals 2 for one answer. And then if I take the 3x plus 2 and set it equal to 0, I'd get x equals negative 2/3. Okay? So taking a look at our original problem, remember, make sure that you know how to plug these back in to check to see that they work, okay, because sometimes we have extraneous solutions that we need to eliminate from our list. But this is the process that we're going to use to solve these rational equations when we have 3 or more fractions. Okay, so I want to thank you for taking good notes, and we'll continue to practice.